All right, so welcome to day 2 of the self-paced work we're going to be doing, the week of 9/23 to 9/26. This is going along with the Independence House programming, so I'm going to be, some of you guys will miss class on different days, so rather than doing whole class lessons, we're going to be doing a couple of self-paced lessons. This is the second of the 2 self-paced lessons that you are responsible for this week. In this one, we're going to be talking about writing and graphing inequalities. So given a description, how do you actually create an inequality and how do we represent that inequality on a graph? So let's start with our first one here. P is less than 3. You want to remember what our less than sign looks like. So we would write that P is less than 3. Remember, the alligator eats the bigger number, so P is smaller than 3. And when it says graph, what it means is let's make a number line. So we have 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And then what it wants us to do is it wants us to shade all values on this number line that would satisfy this inequality. So if we want to do that, we would start at 3. And note that anything smaller than 3, so we would shade to the left of 3. So all of these values over here would be solutions to this inequality. And notice how 3 is an open circle, right? That's intentional. That's because 3 is not less than 3. All right, x is greater than -2, so we can do the same thing. X has to be greater than -2. Again, write our number line. 0, 1, 2, 3, 4, 5. We can go up to 6, sure, why not? And now we want to include, so we want to start at -2, so that's right here. And now it's greater than, so it's all values to the right. So in general, you're either going to shade to the right or to the left. If it's less than, you want to shade to the left. If it's greater than, you're going to shade to the right. All right, now down here, we have Q is less than or equal to 1. So we're going to write Q less than or equal to 1. And we're still going to create our number line. Like that. And so now we're going to start at 1, and I'm going to do a closed circle. And then all values to the left of it. I want you to pause the video and take a minute to think to yourself, why do you think I've closed that circle? Right? What does it mean to have a closed circle there? Pause the video, think to yourself, why does that make sense? All right, maybe you were thinking that it makes sense to have a closed circle because when we have less than or equal to, the 1 is included in our solution set, right? The 1 is part of the solution set. So up here, when it's not part of the solution set, we leave it open. Down here, when it is part of the equal sign, we close it. All right, and then we can do the same thing down here. Y, let me go back to my fine one. And that would be y is greater than or equal to 2. Again, draw our number line, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Now we're going to start at 2. Again, filled in because it's greater than or equal to, and everything to the right. So this is kind of how graphs for inequalities work, right? We're shading all of the values that satisfy our inequality, and then we do a closed circle if it's equal to, and a open circle if it's not. So sometimes you will see wording that might be a little bit tricky. So for example, A is no more than -3. No more than kind of sounds like we would want a greater than, right? We have the word more there, but we actually don't, right? If we think about no more than 3, we want to do all of the numbers less than 3, and we want to stop at 3, right? We can't go past 3. So how do we actually represent this? Well, this is going to be x is less than or equal to -3, right? That is A is sorry, not x, a is no more than 3. Right, no more than actually means less than or equal to, because we're including all of the numbers up to -3. And then if we graph that, we're going to get -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. And then we can go, starting at -3, everything to the right. All right, I included these here because they can be tricky. Because if we look at this one over here, b is at least 5. Again, you see least and you think you might want less than, but that is not true, right? b is the smallest number that we can have. So that means everything else has to be bigger than it. So this is actually b is greater than or equal to 5. That's how we would write that. And if we want to draw that out, we would have -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. And then if we have greater than or equal to 5, well, we're going to start at 5. We're going to have it shaded in, and then we're going to shade all numbers greater than it. So this number line would go on to 7, 8, 9, all the way up to infinity, right? That's what the arrows mean. So anything bigger than 5 would work. I also want to call your attention down here to this note. You can read inequalities forwards or backwards. So x is less than or equal to 2 can also be read 2 is greater than or equal to x. So if you kind of read from right to left here, you would say 2 is greater than x. That's what we see over here. And these are the same thing, right? If you want to think about that, 2 is greater than x. That means that means all values of x are less than 2, which is exactly what we see over here. But that can be confusing, especially when we get to more complicated ones. So I recommend that if you see an inequality like this one, where 2 is greater than x, that you just rewrite it going the other way and you change it to be x is less than 2, right? We're going to see a lot of them that look like this, where the variable is on the left. I think it's just more straightforward to see what's going on that way. So you don't have to. You can do whatever sits right with your brain, but my recommendation is that we write the variable on the left just to keep it clear. All right. And I'm also going to have you work through page 4 right now. And so here we're thinking about there are 2 different ways that we can represent inequalities. So we can represent them with inequality, or I guess 3 different ways. 4 different ways. I've already talked about the verbal description. We've already talked about writing it as an inequality. And we've already talked about representing it as a graph. The 4th way is something called interval notation, and it's another way to write the solution sets for inequalities. So here we're going to take this example, x is less than or equal to 5, and with the interval notation, you're going to use parentheses and brackets, and you're going to essentially write 2 numbers, right? Where the left one is the smallest number that's included in the solution set, and the right one is the biggest number that's included in the solution set. So let's break this down a little bit. Let's just start by graphing this inequality. Then we can make this more tangible. So x is less than or equal to 5. So we have, I'm going to start at -3 here just so that we have more room for bigger numbers on the other side. Now you can start your number lines wherever it makes sense to. 5, 6, 7, 8, 9. And we're going to go to 5, and it's shaded because it's less than or equal to. And then we're going to do all numbers to the left. So when we're thinking about interval notation, we're doing parenthesis or bracket, and then the lowest number included in the solution set. If we look over here, what is the smallest number included in the solution set? Well, that's kind of tricky because it's going to go on and on and on forever to the left, right? So is there a smallest number? No, right? We can keep getting smaller. So we're going to represent this idea with infinity. So we're going to say the smallest number that can be included here is -infinity, right? It's not a number, but we're still going to say we can go all the way back to negative infinity. We want to do that, comma, the biggest number in the solution set, right? The highest number in the solution set. So what is the highest number in the solution set here? Well, that would be 5. So we're going to do negative infinity, comma, 5. And so these are our two numbers, right? The smallest number in the solution set, the biggest number in the solution set. Now, whether we enclose this with brackets or parentheses matter. So if we have less than or equal to, if the endpoint is included, that's when you use a bracket. So for example, for this 5 over here, I know it's less than or equal to, that 5 is shaded in, that 5 is included. So I'm going to put a bracket. If it's not included, so if this were just less than, not less than or equal to, that's when I would put a parenthesis. And importantly, infinity is never included, right? So for infinity, you always put a parenthesis. You always want to use parentheses with infinity because infinity is not a number, it's a concept, so we can't include it. So always use parentheses for interval notation if you have infinity. All right, so let's fill out this table down here. I will invite you to take a moment, pause, see what you can do on your own. So for each of these 5 rows, I've given you one of the 4 ways to describe it. And I want you to work backwards to include the rest of the ways, right? So we want to fill out this whole table. So pause this video, take probably 5 minutes or so, see what you can fill in there. And then when you're ready to check your answers, hit play. All right, so let's go through this now. So x is no more than negative 2. Remember, no more than means less than or equal to. So we're going to write x is less than or equal to negative 2. And if we're graphing, we're going to start at negative 2. We're going to go all the way to the left. We're thinking about this in interval notation. Well, what's the smallest number included in our set? There is none, so we're going to write negative infinity. Right? It's going to go on forever to the left. Comma, what's the biggest number in our set? Well, it can be no more than negative 2. So negative 2 is the biggest number, and it is included, so we're going to use a bracket. All right, here we're going to say y is less than 5. And when we're graphing that, we're going to go to 5. Here it's an open circle because y is not included. And we're going to shade everything to the left, like that. All right, and then from this one, we have a graph. And we can see that, before we do that, we want to do the interval notation for this one. Once again, you can see that we're starting at negative infinity, right? We're going on forever. And here the biggest number is 5. But now 5 is not included, so we're just going to put a parenthesis, right? We're not going to put a bracket because 5 is not part of our solution set. All right, now we can look at this graph. And we can say we're going to start at 2, and we're going to go to the right. So you can say x is greater than or equal to 2. We can write that x is greater than or equal to 2. You can also write that x is at least 2, right? That's an equivalent way to say this. But we're going to go with the more intuitive, x is greater than or equal to 2. And so here, what's the smallest number in our set? Well, it is 2. Is it included? Yes, it is, so we're going to use a bracket. It's going to go on to now positive infinity, because it's going to go forever to the right. And infinity always gets a parenthesis. All right, so for these two at the bottom, we're given the interval notation, and we need to work backwards to get the graph. So what's our smallest number here? Well, it's negative 1. Is it included? No, it is not, because it is a parenthesis. And then we're going to go on to infinity. So we know that the graph is going to look like this. How can we represent that? Well, that looks like x is greater than negative 1, which we can write x is greater than negative 1. All right, and then over here, what is our smallest number? Our smallest number is negative 1, but now it is included, so we can do we can fill in the circle there, and it's going to go all the way on to the right, all the way out to infinity. So how would we write that? Well, that looks like x is greater than or equal to -1, which I can write x is at least -1. If you want to say x is greater than or equal to -1, that is also an acceptable answer for this. You can write it whichever way makes more sense to you. I'm just going to use the at least for diversity here. All right, so this is all of the notes for today. So go on to do the delta math.